All right, we'll go ahead and get started. Everybody see my screen? Make sure. Okay. All right. Well, welcome to AKS Office Hours. My name is Dave Strable. For those of you who haven't met me or new to Office Hours, you can contact me at Dave_Strable on Twitter. I work on what's called our Azure Global Black Belt team. Essentially, we have a much narrower focus within Azure. My focus area is around Kubernetes and the open source ecosystem. I put more to come here because as you know, Kendall moved on to a different role, so we will be having other people from my team that will be supporting us. One will be Alice Gibbons and Ray Kale. They both come from our GBB team out of Canada. Alice is actually on the call, so I'll allow her to introduce herself.
In Canada, as if it was like this faraway place, Dave.
It is, especially when you live in Minnesota.
Okay, well, it's not that far. Yeah. Hi everyone. I'm on Dave's team. Not a ton of a different intro than Dave, but I did post in the chat today that I was able to upload the old sessions on YouTube. So hopefully those will be uploaded kind of more frequently going forward. And yeah, happy to be here.
And Alice likes maple syrup and hockey. Sorry, Alice, I had to put that in there. So why AKS Office Hours? So really AKS Office Hours is to provide customers with updates pertaining to AKS, but also kind of the cloud native ecosystem. Typically, we host a short talk demo around cloud native technologies as they relate to just Kubernetes in general, but also AKS. It's also time for us to collect feedback from our customers on, issues, blockers, use cases, just questions that you have related around AKS or Kubernetes. So feel free. We want this to be interactive, so feel free to put questions in the chat. We also try to leave time at the end just for general questions. So what to expect for our call agenda today? We'll do a AKS and ecosystem updates. Those will be pretty short today. Then we have our product team from AKS that will be talking some roadmap stuff. And then we'll try to leave time at the end just for, ask us anything, customer feedback. And if there are no questions, we'll always end early to give you some time back. Really keep in mind, we want two-way interaction, so stay on mute. But, during question time, you feel free to come off mute and ask questions too, or put them in the chat. We have a lot of people from not just my team, but within Microsoft that can answer questions. Our office hours hosted primarily by the GBB team, but we also bring in a lot of our product group teams to help out too. Recordings content, we'll always try to post those to the YouTube channel and also post the slide decks to the GitHub repo. Sometimes the slides don't always make it there, though. But we try our best on that. If you need to contact us with any thoughts, ideas, questions you have around it, aksofficehours@microsoft.com. AKS updates. 120 has been deprecated. I believe it was deprecated on April 7th. So that's been removed. For containerd will be the Windows default going forward from Kubernetes 1.23. Also starting with Kubernetes 1.23, the metric server will now have 2 pods for HA, so there will be a very small increase in resources from those system pods. Azure tag support has gone GA, so that'll propagate down tags to your resources that get deployed with AKS. Custom node configuration. So if you want to make any, custom configurations to the node for specific reasons, that's also gone GA. GMSNA v2 security policy support on Windows has also gone GA. This is actually off here. What we're covering actually today, so don't look at the dates. The AKS roadmap update is today. Our next session will be the AKS security update with also the AKS PG. The AKS security update will focus just on security features that we're delivering in AKS. Ecosystem updates. So KubeCon will be in Spain and it will also be virtual. So this takes place during May 16th to the 20th. I think for like virtual attendance, it's like $75 to attend. So you'll get, they do post sessions for free afterwards on their YouTube channel. Sometimes now it takes a few weeks compared to it was a few days. Also, the benefit of registering is co-located events. A lot of co-located events, you have to be registered for KubeCon to attend the co-located events. Azure will be having a Kubernetes on Azure Day. That will be May 17th. There was a few other interesting, there's a lot more co-located events. Usually co-located events are usually a half day, full day. Some of them do have a fee for them. Some of them are very minimal fee. Cloud Native eBPF Day, that'll be on the 16th. The rest of them will be on the 17th. The ones I thought were interesting, GitOpsCon, Cloud Native SecurityCon, Prometheus Day, and Service MeshCon. These are probably more interesting because these are ones I've attended previously and always thought they were really good. So check those co-located events out also. For KubeCon North America, I believe that'll be it's like into October, mid-October. It will actually be in-person event, and it will be in Detroit, Michigan. All right, so I am going to hand it over to our AKS PG now, and they will cover the roadmap for us.
Hey folks, so today we are covering the roadmap on a couple of areas. One is fleet and multi-cluster, two is multi-tenancy, and three is networking. So I'll be covering the first two parts on the multi-cluster and the multi-tenancy part, and then the networking part will be covered by my colleague Patrick. So I'll start sharing my screen and let me know when my screen is visible. I'm going to present like a deck on the fleet and the namespace parts.
We can see it.
Okay, awesome. So what is like fleet and what are we here to discuss about in the multi-cluster space? So before that, let's do a quick recap of like where we are with the Kubernetes ecosystem in Azure today. So today we have three cluster types in Azure: managed cluster, connected cluster, and provision cluster. Managed cluster is the most familiar one. That's AKS, and it's been GA for a while. Connected cluster and provision clusters are types under Arc-enabled Kubernetes. Connected cluster went GA last year. Provision cluster is the ability to sort of use Azure Resource Manager to create AKS on-prem clusters on top of Azure Stack HCI or the other on-prem environments that will be added support for in the future. Now, so these are the three cluster types that exist in Azure today, but that's the thing though. So there are only single cluster representations in Azure, and we do recognize that there are some customers where they have to do a lot of repeated gestures across hundreds and thousands of clusters that they have. And there are also some like scenarios itself where having a cross-cluster representation, or rather a representation of a group of cluster, is going to help us. So there in our roadmap, we are introducing like fleet as a new ARM resource. So this is currently in our plan, and we are designing and like sort of working through the implementation. But the idea is that we will have a fleet resource. Think of it as a hub resource to which you can join your AKS clusters or your Arc-enabled Kubernetes clusters. So that way we basically get like a topological model of like a central hub cluster from where you sort of manage all your like actual like AKS clusters. So in this like talk, I'll just give a very like high level overview of what scenarios we want to like address as part of fleet, but at a like top like 25,000 like fleet level, we have sort of like bucketed those scenarios into different verticals. So identity is one, workload orchestration, networking, resource orchestration, and so on, where all of these are sort of like on how you do these things across like a collection of clusters centrally from the notion of a fleet. Now, first for identity. So in one of the previous talks, I saw that Michael sort of like gave a overview of the workload entity federation, and that's the feature that we have in public preview today. Where you are today like doing a federation between AD identity, which is either a service principal or in near future managed entity. And on the cluster side, you're doing the mapping with the clusters unique OIDC issuer, common namespace, common service account, where the issuer is like the clusters OIDC issuer is the issuer part and the subject part is the namespace, common service account. But the thing is, that's good like when you have like individual clusters, but what about like customers who have hundreds and thousands of clusters? So in that case, the federation mapping, we are doing them on a per cluster basis. So that becomes sort of like a scale problem, and also like on day N, you may add more clusters, you may remove more clusters. That's a problem as well. So there, from a fleet perspective, we want to tackle fleet level identity federation, where you do the federation mapping just once for the fleet from an issuer perspective, and then for the subject, like you do the namespace common service account. So that way, even if you're deploying the same application across all of those clusters of the fleet, you are doing the federation mapping once, and then whenever a workload and a service account in one of those clusters wants to speak to Azure, it is able to sort of like reach out to AAD and then exchange the service account token for the AD access token, and then hit Key Vault or Cosmos or any of those AD protected resources. So that's workload entity federation and fleet. Next, we also have AD RBAC. So AD RBAC, there's a feature in GA on top of AKS today. So it allows you to use Azure role assignments instead of cluster native Kubernetes, like the role binding or the cluster role binding as the authorization enforcement options on the cluster. So today, like when you have again like hundreds of clusters and hundreds of namespaces in each of these clusters, which is pretty common of a pattern that we have seen in the customers with large platforms and such. So there, it very quickly sort of like shoots up the number of role assignments that one would have to perform. And there, every subscription having a limit on the number of role assignment. One, it's a scale problem, and two, also it's a flexibility problem in terms of one, how do I pick out a specific permutation of clusters or namespaces and only give permissions over there, as opposed to doing a permission grant at the resource group or the subscription level and have that applied across all the namespaces without like any flexibility. So that's the problem that we are dealing with before Fleet today. Now, after Fleet, the Fleet resource itself will be a hub cluster, and the platform admin can create namespaces on top of those hub cluster, and then they perform those role assignments on those namespaces. And from there, whenever a request is coming into any one of these namespaces on the member clusters, which are the clusters represented in green, these authorization checks are done based upon whether a role assignment exists over here or not on namespace A or namespace B in the fleet resource. So that way we're able to sort of see that one, the platform admin gets a central place from where they do all of these role assignments, and two, we under the hood are handling all the access propagation to all the member clusters. So this way you're not running into scale limits, or you're not losing out any of the flexibility of the role assignment. So this is on identity. Next is on workload orchestration. Workload orchestration, this is actually related to the multi-cluster SIG upstream. So multi-cluster SIG, there has been a couple of projects over the last 2 years. KubeFed has been one, and also there are a couple of other projects from like different like cloud providers over there. So KubeFed took a approach like where you have to like create a federated deployment, federated replica set, and so on. And from like the central hub cluster, you can propagate that workload to all the other clusters. But there were a few of the limitations there with KubeFed. In that one, you have to create a federated deployment and all of those objects, right? The federated like custom resource variants. So even before the requirements of the scenarios, one of the first things that we are thinking of from a constraint perspective is whatever like central like platform approach we take to workload orchestration, we honor the fact that like there exists a good amount of like ecosystem in the form of Kubernetes manifests or mcharts, and we try to provide like a transparent way to apply those, as opposed to like customer having to sort of reauthor all of those in terms of a federated like variant of the custom resource. So there, that being the constraint, what are the scenarios that we're looking at? So let's say I'm a platform admin and I want to give my application developers, the consuming teams of the platform, like way to deploy their application across all the clusters. Now, the application developer themselves don't need to be aware of all the clusters backing that fleet, but they just need workload of the team A namespace to go to all the team A namespaces. Where was this example? Yeah, so if we take this example, so the application developer of team A, they just want to deploy their applications over here on namespace A, and then behind the scenes, how many work clusters were there, whatever is the most optimal mechanism to dispatch those workloads on all of those clusters, it should be possible. Now, on that note, what are the scenarios that are there? One, one should be able to use Fleet to deploy to all the clusters the same workload. Second, deploy the workload to a specific set of clusters where you identify the clusters by name. Third, deploy to a specific, or rather exclude a specific set of clusters from deployment. Fourth, deploy, but in a way where you use label selectors. So just like you have pod selectors, node selector in the case of like pods and nodes. So if we elevate that one level up, so we have clusters and then cluster selector, and then being able to deploy namespaces or actual workloads to a specific set of clusters based upon cluster selector constructs. So that's 4. 5, being able to pick out clusters based on like cluster selector, but within those Y set of clusters that got picked out by those label selector constraints, how do I rank order those clusters, the X clusters based upon certain advanced heuristics? Now, those advanced heuristics could be resourceability. Let's say I want to pick out like the topmost X clusters where I have the highest available like resources still available, whether it's memory or CPU, and then I want to dispatch the same workload, the same deployment -ABC to all of those clusters. That should be possible, and that's what scenario 5 speaks about. Scenario 6 is where it's not replication anymore. The scenarios 1 to 5 were like replicating the same workload across all those clusters. Scenario 6 is on how do I have like an aggregate workload that I can sort of like split across. Now, from a scenario perspective, how would that look like? Like me as an application developer, I just want like 100 replicas deployed across all my clusters and maybe the East-West region, but I don't care about how many of those clusters those workloads or rather those replicas are deployed into, and which of those clusters those replicas are deployed into. Now, from a split perspective, 2 scenarios within split. One is a weighted split, and 2 is an even split. So in even split, let's say you have 20 clusters and you have 100 replicas to split. So each cluster gets like 5 replicas. And then in a weighted split, you're splitting again based upon some advanced heuristic, which could be resource availability. So the cluster with higher amount of resources still available will get the higher amount of replicas as part of the spread. So these are the few of the scenarios that we're looking at from a workload orchestration perspective. By the way, the other constraint that I forgot to mention is that it's not just about the transparent application of what is that, the manifest or the Helm charts, but we should be able to sort of like support these workload orchestration constructs at the more platform level, at a fundamental level, so that the GitOps or pipeline or any one of the like deployment tooling that you have, you're able to use it as opposed to us sort of like enforcing a specific way of doing it. So we want to take an agnostic approach and then have your tooling be still applicable on top of the fleet as well. Okay, so at this point, I'll take like a small pause. I'll see the questions on the chat and I'll answer them, try to answer them, and then I'll get back as well. So is Fleet kind of like a firewall manager? No, Fleet is more of, think of it like a hub cluster from where you sort of centrally manage your member clusters. One, like on the workload orchestration I've spoken about identity, we have a few more slides coming up in the multi-cluster networking and then the resource orchestration space. So it's more of like a central like way to sort of orchestrate. Second, okay, I see questions about deck. I don't know good way to share the deck, but I seen that like the previous GBB, like the YouTube videos, they have been shared on YouTube. And so this like video will be shared on YouTube over there. And similar to how Michael presented the workload entity roadmap, we should be able to share that deck on, or rather the YouTube video of that, which is what Alice, I think, uploaded as well. So I'll work with her on that. Next, I'm wondering, central firewall policies. I'm not getting, okay, specifically on firewall. So there is a slide coming up on the resource orchestration later in the slide deck on how you can bring up AKS clusters on the fly from the fleet itself. And that like any sort of like configuration that you wanted to do specifically for the AKS cluster, you can do from there. And on fleet level, like multi-cluster like network policies, that's a good topic. Right now in the upstream multi-cluster SIG space, there is thoughts on how to do east-west networking using multi-cluster services API, and north-south like using gateway, and where you have like a load balancer sit in front of multiple clusters. But network policy is an evolving construct, and I think we will need to sort of like watch out how like upstream sort of space takes an approach on this, and then accordingly like build our plans as well over there. Can fleet be used with Lighthouse? I can't like commit for sure, but it should be possible because Fleet is an ARM resource and Azure Lighthouse is sort of providing you a multi-tenant like view of like managing your ARM resources. So I think most likely yes, but I mean, as we form our roadmap like over the coming few months in terms of private preview, public preview, we'll start incrementally rolling out like the Fleet resource itself and also all the features there. Yep. Richard's last message. Yeah. Think of it like as one like hub cluster to rule them all. It's kind of that way. Yeah. No, Fleet is not a proprietary. It's not a network policy engine. It's got actually nothing to do with network policy. It's more of like, hey, having a central like cluster from where you can actually like sort of centrally orchestrate like identity scenarios or workload orchestration scenarios, or the networking scenarios and so on. But it's not restricted like to network policy. In fact, we don't have like any immediate plans for network policy. We need to watch out for how the network policy story evolves in the multi-cluster SIG space. Okay, so coming back, next is networking. So networking, this actually like we are sort of like taking a provider approach to the upstream APIs. So in the upstream space, there is a multi-cluster service API. So it's a Kubernetes enhancement proposal. A lot of the cloud providers are backing this and writing provider implementations. What we as Azure want to do is also like basically write a provider implementation for multi-cluster service API as opposed to coming up with our own API. What is multi-cluster service API in the first place? So there is service export and service import object. So let's say there are cluster 1, cluster 2, cluster 3, so on till cluster 100 in a fleet. Now, bar service only exists on maybe cluster 1, but not on any other service. So to make the other clusters aware of the bar service that exists on cluster 1, one would create a service export object referencing that bar service on cluster 1. And then us as a cloud provider, we watch for those service export objects and then create service import objects on the other clusters. And the endpoints of that service on cluster 1 are available now on cluster 2 as well. So with the first scope that we make this like feature available for AKS clusters where the pod IPs are coming from a subnet specified by the customer. So if you're on the same VNet or if you're on peered VNets or even potentially globally peered VNets, then with that all being a flat network between these clusters, you're able to communicate from one, like let's say a foo pod in one of the clusters to a bar service in another cluster. So that's for the east-west scenario. Next for north-south. So think of it like having like a L7 load balancer in front of like multiple services, maybe even the same service deployed across multiple clusters. Now, how would that work? Now, from an API perspective, again, we are sort of like taking a cue from upstream. We don't want to reinvent the wheel. Gateway API is now sort of like being thought of as an evolution of ingress, where ingress has existed for the longest period of time, where you have like an ingress object, you do the TLS termination there, and from there you route the traffic to multiple services within a cluster. Now, gateway takes it one step further. Gateway can do everything that ingress can do, plus it has granular separation of concerns or granular authorization separation between who defines the gateway object versus who defines the route objects. So in ingress, the routes were defined within the ingress object itself. So if you needed a split between the cluster operator, the platform admin versus the application developer, it was a little tough to achieve. But with gateway, these objects being different, the cluster operator, the platform admin can sort of manage the gateway resource. Whereas the application developers still get the flexibility to define their own HTTP routes because they're the ones writing the application and deploying those applications. Now, what are we as like Azure doing? So we'll write a provider implementation for gateway, provide like a regional gateway class, L7 regional multi-cluster gateway class, and then global L7 multi-cluster gateway class, so that you can create an L7 gateway. And then from there, it routes traffic to, let's say you have a site service deployed across maybe East US or West Europe. So in the global case, it's Anycast POP at the Azure provided like L7 LB resource. And then from there, we route the request to the whatever cluster we have set up the forwarding rule for. So if the request is coming in from the East West cluster, we can choose to, or rather the request is coming from the East West region, we can choose to route the request to the East West cluster. Or if it's coming from a different region, we can choose to route it to a different region. So that should be possible. Or if you just want to use a regional L7 load balancer, that should be possible as well from a north-south perspective. So these were like pretty much all the experiences that we had. Developer experience I'll not get into. It's still kind of evolving. Resource orchestration, what is it about? So we have had cluster API provider Azure, and Azure managed cluster as a custom resource existed in cluster API. It's an experimental feature right now, progressing towards V1. What is it about? So it gives you a Kubernetes native YAML file, or rather a Kubernetes native object to create an AKS cluster itself. So you create a Kubernetes native object, there's a controller watching it, and then that makes an ARM API call, Azure Resource Manager call, and then it creates an AKS cluster. So us as Fleet, what we want to do is integrate cluster API provider Azure as a managed add-on within Fleet, so that you can just define your like custom, Azure managed cluster custom resource, having the specifications that, hey, here is my AKS cluster, here are all the specifications of the AKS cluster, and then the AKS cluster gets created, and then it gets joined back as a member cluster so that it becomes eligible for workload placement and so on. And then also there is Azure Service Operator for creating Azure Container Registry or Azure Key Vault and other resources, being able to use that to sort of like create all of those resources, like integrating that with Fleet as well as another part of the story. So these are all the scenarios that we have at a very top level. So from a roadmap perspective, how we are approaching this is, one, we are targeting like a private preview sometime like around the August timeframe, and then like public preview sometime maybe towards the end of this year. So this is where we are at. Okay, so I again see a few questions on the chat window. I'll quickly take those, and then after that, hand over to Patrick. So just give me a second. I'll come back to the chat. Will this cluster be just this, or we have to look after everything, or will it become more like a resource we can consume? That's a very good question. I think in the our future plan is to have like the Fleet resource as a managed cluster, so that like the version upgrades and so on for the Fleet we are able to sort of provide, and then you are just able to use that as a control plane. From where you can actually manage all your other AKS clusters. So from MVP perspective, we'll support joining existing AKS clusters, and then also in future support creating new AKS clusters itself, and then centrally from the Fleet you should be able to manage all of them. But the Fleet itself, I think we will strive to go towards a more managed experience with the Fleet resource, because it's just like a control plane, but not for the deployment of your workloads itself on the Fleet. Next, does the gateway work with the Nginx ingress controller? I think it's TBD. We are more focused on what is the characteristic of the scenario that we want to achieve. From a scenario perspective, we know that the customers want one, a regional L7 like north-south ingress, and two, a global north-south ingress. Now, how we achieve that, I think there are a couple of approaches. I think one is we provide like an Azure managed L7 load balancer. So something like an application gateway or front door, or maybe even a new one. But we have the managed L7 LB resource from where we provide that load balancing capability, and also we provide you the capability to configure like multiple backend endpoints across like clusters on that load balancer, and that being predicated on the clusters itself coming from a flat network like VNet, where all of those clusters in the pod IPs are getting derived from a subnet that's specified by the customer. Next, I can see this being crucial for DR scenarios, ingress. Okay, that's a very good question. So if you have a global L7 load balancer, you can actually swap out the traffic yourself. So let's say an entire region goes down, like God forbid, let it not happen. But let's say worst case, let it happen. I mean, if it happens, Then if you have like, let's say, active mode of deployment of the clusters across multiple region, the global L7 load balancer should be able to help you sort of like divert all the traffic that is meant for one region to the paired region for that particular region, so that you're able to still serve all the traffic. Next, address question on ingress gateway. Next is hybrid stuff from Microsoft. Would it not be better to use Crossplane rather than ASO? Okay, Crossplane, ASO, Microsoft, there are other Crossplane, ASO, and hybrid. There are three different like topics. One, with respect to hybrid, we will support like AKS and ARC-enabled Kubernetes clusters. So let's say you have a non-AKS cluster, whether it's a GK cluster, EKS cluster, or a cluster on your laptop, or like a AKS on-prem cluster where it's AKS on HCI cluster. You'll be able to ARC-enable them, like first connect them as ARC-enabled cluster and then connect them as Fleet. So Fleet, our MVP scope is AKS, and then like at a later point of time, maybe like a couple of months later or the next year, we will start taking a look at ARC-enabled Kubernetes as well. Next, Crossplane or ASO. Like both of them are in the same space with respect to being able to provide the Kubernetes native way of creating like multiple resources in Azure. Like with respect to Crossplane, that sort of like is now going beyond like Azure. If we are able to like get customer requests for that, yeah, sure, we can maybe consider that in roadmap. But right now we do not have any plan for Crossplane. We only have plans for Azure Service Operator and Cluster API Provider integration into the Fleet. Can this manage existing clusters, or do we need to redeploy all the child clusters? No need to redeploy. Our MVP scope itself is going to start with existing clusters. So the first operation is AC Fleet create, but the very next operation is AC Fleet join. So you can join your existing AKS cluster into the Fleet for management. This is more like Rancher or OpenShift, but Azure managed. No, not like OpenShift. OpenShift is another distribution of Kubernetes. So it is not trying to create another distribution, but we are trying to sort of provide a central fleet or a hub experience from where to manage like multiple clusters. Is it more like Rancher? Rancher is more into the space of one, the lifecycle management of the clusters, and two, there's also the Rancher Fleet like provided where you can do GitOps across multiple clusters. I think we are taking a we'll address those two areas as well, as I've already covered in the deck. But also we want to take a go broader than that in terms of the networking scenarios and so on. We know that there are these needs for regional L7 load balancer in front of multiple clusters, or global L7 load balancer in front of multiple clusters. How do we provide an Azure managed experience for that? And then from a workload orchestration perspective, not just GitOps, but the sort of scenarios that I went through. How do you pick out a subset of the clusters to deploy the workloads to? How do you override the cluster specific set of clusters to deploy the workloads to? How do you have an aggregate workload that you split across multiple clusters? So there are more like a broader set of scenarios in the multi-cluster space where we are taking like a holistic view of that space and then addressing those needs like scenario vertical by vertical in Fleet. That's the approach that we're taking there. Okay, so those are all the updates that I had on multi-cluster. A quick update I forgot on multi-tenant, which should take just a minute. So right now in AKS, we have like AKS as a single cluster. So from a multi-tenancy perspective, we have a couple of asks on providing scoped access to log analytics based upon namespace level. So one, we have a namespace as ARM resource like feature under the work. And we are targeting like a private preview of that particular feature around the June timeframe. So when that happens, you get a namespace as an ARM resource under the AKS cluster. And then on top of the namespace ARM resource, first and foremost, we'll support Azure RBAC, where you can do a role assignment from the portal. And then iteratively, like month over month, we'll keep adding more features. And subsequently, the target is to get like scoped access to log analytics. So if you have permission only, read permission only on a namespace, you should be only given permission to read logs of that specific namespace, but not other namespaces of the cluster. So that's an experience that we're working towards in the second half of this year. Yep. Okay, so those were all the updates I had on multi-cluster and multi-tenancy. Over to you, Patrick, for networking.
All right, you did get one more question that just came in.
Oh, can this work with AKS cluster that are internal only, that is abstracted behind API? So Fleet, it can address any cluster which is how do I put it? Which is in the same tenant. So in the first year, at least in our MVP scope, we'll support like joining clusters as same tenant to the Fleet. So if it is a cluster like from different subscription or like same subscription or same resource group or different resource group as a Fleet, all of those are supported as long as they're in the same tenant. Private cluster, public cluster, both should be possible with from the joint perspective for Fleet as well. Yeah.
All right. So Shashank had his one big new project to talk about. I have a bunch of little ones, so I don't have a nice deck. I just have GitHub and our project board, or our roadmap board. We do tend to go through this once a month, I believe, but I'm going to go through it from the networking focus only, and so it should be much shorter. So things we have going on, as you've seen if you follow the release notes, accelerated networking for Windows nodes just released very recently. So that's always good to hear. It helps with your CPU utilization, everything else in terms of network processing. BYOCNI, or Network Plugin None, went public preview recently. So that allows for Kubernetes clusters, AKS clusters, to deploy with no CNI plugin enabled whatsoever. Your nodes come out, they deploy with, they show up in not ready state because there is no CNI. And so you can then bring any CNI you want on top of that without having to coexist or overwrite either the kubenet configuration or the Calico configuration. And I was actually going to mention Richard did write a very nice blog post about that as well. So he just dropped it in chat conveniently. Saves me having to go find it myself. That is going to be moving forward, and not surprisingly, it works very well with the open source distributions, and the vendor supported distributions are also going to be updating their documentation to make use of that as well in the very near future, I imagine. AKS in behind HTTP proxy, this is sort of a weird feature where it's kind of in the Windows space, it's kind of in the security space, and it's kind of in the networking space. It is in public preview. The main thing stopping it going GA right now is not AKS itself, but it's add-on support. So we're still working with the Defender for containers and log analytics agents to have them properly import and use the proxy configuration. So it works perfectly from the AKS perspective. We just need to get the add-ons going with it. Once that's done, that feature should be able to go GA. Next up is a feature that is, this is called creation of node pool in different subnets. You might hear it called pod subnet. You might hear it called CNI v2. Basically, this is a feature where you can go out and delegate a subnet to AKS and have your pods injected into that subnet. That means your nodes and your pods are no longer coming out of the same address space, but the pods are still VNet addressable. So it's kind of, it's similar to KubeNet in that the pods and nodes aren't in the same subnet, but it's similar to Azure CNI in that the pods are getting VNet IPs. Additionally, it is much more efficient on IP address assignment than Azure CNI v1 is. So while we still assign a couple IPs to each node to be able to be quickly assigned to pods without having to go out and talk to the network controller, that is much reduced from the default 30 that Azure CNI assigns. So you'll find that there's a lot less overhead and unused IP assignments in a cluster with Azure CNI v2 or pod subnet. And that should be going to GA in the very near future. It's been a very long preview, as you may be able to tell from the date on the comment. We were waiting for a feature to come in from upstream from Azure Networking, not Kubernetes upstream, sorry, Azure Networking upstream. And that has finally finished rolling out. So now that that's done, we can move forward with our GA process. Sorry, I was talking about the wrong thing. This is the one I just talked about. This is node subnet, which allows you to have your node pools in different subnets so that you can have clusters with, you know, if the subnet you're deploying it to initially is not big enough, you need to expand, you can add in a second subnet and start putting node pools in that second subnet at creation time. That is at creation of the node pool, not the cluster, so you can add it to existing clusters. However, it is not cross VNet. It does need to be within the same VNet right now. That has also been in preview for a very long time. The reason that that hasn't gone public GA up until now is because there were some issues with how kubeproxy handles subnets. It expects everything to be in the same subnet as nodes. There's no way to add more than one. So there was an upstream feature that was just added that will be in Kubernetes 1.24 to support having kubeproxy figure out what subnet it's in based on the primary interface of the node. And that has been backported to 1.23 for AKS. So that will roll out with 1.23, which just GA'd. And so this feature will be going GA very shortly. AKS for IPv6, that is happening now with KubeNet. That is in public preview. It will go GA once a networking feature is fixed to allow for external traffic policy cluster services to work correctly with IPv6 front ends. So the networking team did commit to that for the copper semester, which is April through September. They're working on it. Once that feature is done, that will then roll downstream to us, and external traffic policy cluster services will start working reliably, and then we will be able to GA this feature. There are certain other requests where people want to have Azure CNI Azure CNI IPv6. Base Azure CNI IPv6 is blocked by the fact that you can't have more than one secondary IPv6 address. That's not likely to be coming in the immediate future because that work to enable that is not happening this semester from networking. There is we are working on getting that supported under Azure CNI though, and so hopefully we'll have some announcements about that later this summer. API server VNet integration is out there. That's been open since January, where the new method for handling private clusters will be using the same technology that's behind pod subnet, where we inject your pods into a different subnet, to actually inject your API servers from the AKS underlay into your subnet. That means that all communication between the pods and the nodes can happen directly within the VNet boundary. There doesn't need to be a tunnel, so no SSH tunnel, no OpenVPN tunnel, no connectivity is required for these V2 clusters. We expect the reliability of the API server communication to be a lot higher in terms of not having as many details that you need to get correct day one for provisioning to happen, especially in enterprise environments. Just fewer things to work through in firewalls and everything else. Private cluster is going to come first, and then public cluster V2 will come a few months after that, I believe is the current plan, just because there's a little bit of extra infrastructure to build on. A call out there is that the public cluster V2 is going to be built on top of private cluster V2. So once that moves forward, anything that's deployed using the V2 method where you delegate a subnet for your API servers will always be a private cluster. In terms of the API to node communication will be private, and you'll be able to turn public on and off. So you'd be able to take a cluster that was deployed as private and make it public, and then vice versa. Richard, just because I happen to see your question come in, initially it's going to be new clusters only, but we are working on a migration plan. So that should be something that we'll be able to migrate after the fact. However, it is not ever going to be anything that we'll be able to automatically migrate, at least for BYO VNet clusters, because it does require you to create a subnet and delegate it to AKS. In a managed VNet, we can go ahead and potentially do that for you as a single upgrade step, but for a BYO VNet, our service principal, our identity is almost certainly not going to have the ability to create that subnet, nor would we know what you'd want the IP addressing to be or anything like that. Next up, this one is tangentially related. Being able to assign the install InfiniBand drivers for N series with the InfiniBand and the H series VM SKUs that have it. This is mostly useful for HPC. Right now, you can deploy CNI, or sorry, I'm trying to look at questions and talk, and I can't walk and chew bubblegum apparently. You can or will be able to very shortly deploy node pools with a single placement group turned on, which allows you to make use of InfiniBand. However, we don't currently automatically install those drivers. So if you want to use HPC with InfiniBand communication, you have to add them yourselves with the daemon set. We are working on the ability to get that added in automatically so that you can just deploy an HPC node pool with RDMA enabled, and it will have all the appropriate drivers and everything that you need. Work is ongoing to enable IPVS support for certain customers, well, for everyone, but because certain customers need it. If you're not familiar with the difference between IP tables and IPVS, IPVS is a much more intelligent load balancer that is still built into the Windows or Linux kernel for your Kubernetes internal load balancing. One of the big things is it supports, for example, weighted round robin or least connection profiles, rather than just doing the straight statistical random that IP tables does. This doesn't make much of a difference if you have 100,000 short-lived connections, but if you have connections, say, between an app tier and a database tier where you have 3 connections and they're very long-lived and continuously reused, IPVS can help keep those a lot more balanced than just the straight randomness. And then this is one that I'm driving right now with static egress for AKS. So the idea would be that you'd be able to go in and either annotate pods or use a label selector on a binding object. We're not quite sure what yet. And then have all of the pods that match to this given static egress configuration always egress their traffic from a given IP address. Or in this case, it'll be a small CIDR, so likely a /31 or /30, depending on what you pick. So that will enable you to have outbound firewall rules. It will enable you to have inbound firewall rules on the far end of connection destinations, and allow you to manage and map your traffic a lot more easily. That is on a per pod basis, so you could have multiple IP configurations inside a single namespace. If you wanted to, you could have one that's used in multiple namespaces, however you want to set it up. It is currently a gateway situation where there will be a special, likely a special node pool deployed that will act as gateway nodes and have the public IPs assigned to them. We're working on more seamless ways to do it, but we don't have it right now. All right, that is the last item I wanted to hit, so let me scroll back and start going through questions. Okay, so Azure CNI is not more or less secure as compared to KubeNet. It does have some potential advantages in terms of being able to directly address the pods on the network. So as an example, if you were using a firewall NVA in the same VNet or modified your IP mask CIDRs for subnet or for SNATing, you could potentially see what the pod IPs were on the source traffic. But that's really the only secure, in quotes, I guess, you would have out of that. KubeNet's big advantage is that it doesn't require the address space in the base VNet. Azure CNI's big advantage is that it is a purely routed protocol. There's no L2 bridge in it, and you can directly see the IPs. The performance difference between them is pretty minimal in terms of standard traffic. Now, if you're seeing tons and tons and tons of, like you're flooding the NICs on these machines, you will potentially see a little bit more CPU utilization out of KubeNet, but it's generally pretty minimal. So it just comes down to, do you need pod native IPs or have plenty of IP space and just want everything in a flat network, or do you want the overlay? The other big difference with the overlay, though, is that because KubeNet relies on route tables and host networking, it isn't currently supported on Windows, and it currently caps your cluster size at 400 nodes. Let me see. Pod subnet as a feature will GA it for all versions that support it. So it's not going to be like preview on 1.22 and GA with 1.23. It will GA when the feature will GA across all supported versions at that time. Let's see. The CNI that doesn't pre-allocate IPs is the pod subnet feature. That's this one here, the dedicated subnets. So that is a public preview feature, and it's built on the same technology as the API server VNet integration, but it's not directly related aside from that. Let's see. Yeah, the biggest reason most people use KubeNet in terms of the arguments is just basically because it doesn't require that big IP space. There is currently some work going on to try to come up with alternatives for KubeNet that don't have the 400 routes, but nothing that is ready to be announced yet. Let's see. Private cluster V2 is soon. We don't have an exact fixed date, but I mean, we're aiming for middle of the summer at the latest. So months. GA date is also not, or for pod subnet is also not fixed yet, but I believe the last thing that we were waiting on for that to GA has been rolled out. So within the last week. So once I get that confirmed, then we will be able to move forward and get a firm GA date and get that announced. Let's see. I think that was it. Maybe the only thing to go back to right now is with BYO CNI, there was one note I missed, and that is that Azure's network is a layer 3 routed network, which means that if you are using Calico or Cilium or anything else, you need to make sure it is using encapsulation. You know, Richard covered that in his blog post about Cilium using VXLAN encapsulation. Calico works really well the same way. Calico can also use WireGuard, but I believe that doesn't work on Azure until 3.23, which is just getting released, Calico 3.23. So you do need some form of encapsulation because you can't directly route packets without using some form of route table. Shank, you got your hand up? That actually ends what I had,
Oh, no.
So if there's any more questions.
I think that's my mistake. I don't know how that went up. Okay, some bug or something on my keyboard. Okay.
Yeah. Control Shift K. Anyway, I think I got all the questions, and that's all I had. So Alice and Dave, if you have anything else to wrap up, I will try to keep an eye on more questions. And
if there's, oh, go ahead.
Sorry, I was just going to say, yes, VXLAN, if you're not using accelerated networking, there is going to be a little bit of performance impact because you are encapsulating packets, and you can require things to fragment as well, because if you're sticking a max size packet into a VXLAN encapsulation, that'll have to be fragmented. However, that's also something that's relatively minor unless you're doing something that's really network heavy. So anyway, Dave, sorry.
Yeah, just wanted to thank Shashank and Patrick for joining today. The discussion was great. A lot of great questions out there. Hopefully everybody liked this format a little better for the roadmap. You know, instead of doing, you know, the 50 different features, we were able to kind of go deeper on specific things here. So we'll try to do that in the future too for these roadmap calls. So thank you everybody for joining today. As always, feel free to reach out if you have any suggestions or comments. Thank you.